Let's take a look at how to provision a Spark cluster in Azure. So I'm going to go and search for my HDInsight service. Now I could actually go and browse for it in the Data and Analytics category here. But these things have a habit of moving around sometimes as the portal gets updated. So I'm just going to search for it. So if you don't know where it is, you can go and search for HDInsight. And it will come up in this list of results. So we'll go and just grab that and we'll create an instance of an HDInsight cluster. Now there are some default values that you can use. So you could do a quick create option here, or you could do a custom create, in which case you'll have to specify all of the values yourself. I'm going to use custom because I want full control over what my cluster looks like. So I'm going to give it a name. We'll just call this, well, if I put in something like test, for example, you should see it goes and checks here, and we should get a little warning here. Yeah, there we go. There's a little warning there saying that that name is already taken. This has to be a publicly accessible name. It's actually whatever you put here, .azurehdiinsight.net, and it's available on the internet. So it has to be completely unique. So we'll choose something like SPK012345, and hopefully that one is unique. Yes, so we get a little tick. We're able to use that. I'm going to put this in my current subscription. If you've got multiple subscriptions, you can select the one you want to use here. And the next thing we have to do is specify the type of cluster that we're creating. And the cluster type in this case is a Spark cluster. So we'll go and select Spark. And that's only available in a Linux operating system. And I can choose the version of Spark that I want to run. So I'm going to choose the very latest version, which is it's actually HDInsight version 3.6, which is running Spark 2.1.0. So we're going to run that version of Spark. You choose the appropriate version for whatever applications you're building. And we're going to use our standard tier here and go ahead and select that option. So the next thing we need to do is specify a username for our cluster. So I'm going to specify HD user. The default is admin, but I always like to change that to something else. And I'm going to specify a password for that user. So I'll just type that in. Now you'll notice that it's also asking me for another username, and this is something that's important to realize and to remember. There's a username that you use when you connect over HTTP. So for example, if you connect through the Azure portal to the dashboard for the cluster, you'll log in using your HTTP credentials, and that's this cluster login, so HD user in this case. But occasionally you'll create a remote shell connection, a secure shell connection, SSH console window that you connect on your local machine to the nodes in your cluster, or to one of the head nodes in your cluster. And in that case, you use a different credential. You use this SSH user username. So whatever you type here is the name for that user. So there's two different types of users. You need to be aware of which one is required depending on how you're connecting. And I'm just going to keep the same password just to save me getting confused. You could specify a different password if you want. Now we need a resource group into which we're going to put this cluster. So I'm just going to create a resource group which I'll call HD12345 for all my related resources. And that's okay, I haven't already got one with that name, so that gives me a little tick. And I'm going to create this in the East US 2 data center. You can actually choose the data center where you want the cluster to be stored. I'm just going to choose the default one there and click next to move to the next step. Now in the next step I get to choose where I want to have the storage for my cluster. The cluster will consist of multiple virtual machines, which we call nodes. And they will need shared storage in which they will work on the data. So I need to specify where that shared storage is going to be hosted. And I can choose either an Azure Storage account or a data lake store. Now for large volumes of data, if you're doing some serious big data processing, you're probably going to use data lake these days. But Azure Storage is nice and easy to work with, and I may already have applications writing data to there that I want to process, so sometimes Azure Storage is the right option. So I'm going to leave it on Azure Storage. And I could choose an existing storage account from my existing subscriptions, or I can create a brand new one. So I'm going to go and create a new one, which I'm going to call HD AZ Store 12345, just to make sure it's a unique name. So I get this global unique name for my storage account. And I need to create a container, because this is an Azure Storage account. I need a blob container in which I'm going to store my shared files for the cluster. And just to make things easy, I'm going to give that the same name as the cluster, so it's nice and easy to identify which container is associated with which cluster. So I can do that. I could add additional optional storage accounts if I want to, if I need to work with data from different storage accounts, or I could add a data lake store as well, if I'm going to be processing data from Azure Data Lake. I'll leave both of those for the moment on those. You've also got the option of where you want to store the metadata for your cluster. There's metadata for Hive and for Oozie, which you can store in an Azure SQL database. By default, it'll just create a private database for those, but I could choose an existing database if I wanted to manage that metadata myself. Next, I get to choose which applications I want to have available on my cluster. So there are applications here. In this case, they're not compatible with the cluster configuration, it warns me, so I can't install those. But if there were any that were compatible with the version of Spark that I've chosen, I could install those as part of the provisioning. And then on the next page, I get to choose the cluster size. So in this case, we've got a cluster that by default has 4 worker nodes, and then it will have head nodes as well. It'll have 2 head nodes that act as the kind of managers of the cluster, if you like. Well, I'm really only going to have 1 worker node for my demos here. I'm not going to be doing any big major heavy working, so I can have 1, and you can see that reduces the price. This is the cost per hour of running the cluster. So reducing it down to 1 just for learning about Spark is probably a sensible thing to do. When you're using it in production, you'll want multiple nodes because that's how you distribute the workload. The other thing you can do if you're really tight on cost is you can go in and change the size of the worker node. So by default, it's chosen this D4v2 size here. This is the virtual machine that's going to be used, and you can see the cost per hour to run that virtual machine. I could actually go and choose a smaller size of virtual machine. So I could go and choose this general purpose one here, which is slightly reduced in price, and that should knock my price down again. Now you have to be quite careful doing this. If you choose something that's too small, then what you'll find is it will reduce your cost, but some of the services might not start, or they might fail, or your cluster might run out of resources. So you want to be pretty careful about choosing the appropriate size of the nodes. I'll go ahead with that and click Next. And then I can specify any additional script actions that I want to run after the cluster is deployed, perhaps to set some configuration or to install some additional components. And also, if I wanted this cluster to work with perhaps other resources in my Azure subscription, maybe I have as well as a Spark cluster, I might have a Hadoop cluster or an HBase cluster or something that I want it to work with. I could specify a virtual network that would allow them to connect directly to one another without having to send traffic across the internet. So I could create a virtual network. In this case, I'm just going to leave that and move on to the next step. And then I'm ready to review the summary of everything I've chosen and go ahead and click Create. And off it will go and deploy that cluster. Now, it typically takes around 20 minutes to deploy a cluster. Normally, you would either sit here and wait or go and take a break and have a cup of coffee. Thanks to the wonders of video editing, it should happen pretty much instantaneously for me. And when the deployment is finished, I get a little notification here, and the blade in the portal opens up so I can see my Spark cluster. Now, there's a number of things that we need to look at here. You can see there are various options here for dashboards and secure shell and so on. So let's just take a look at how we can work with our cluster a little bit. I'm going to click this dashboard link, and that will open up another tab, and it's going to ask me to log in. And if you remember, when I provisioned, I specified an HTTP user account with an appropriate password. So we'll just use those HTTP credentials to connect. And this is going to open up the Ambari dashboard for my cluster. Now, the Ambari dashboard is basically a way of me getting a good overview of all of the services that are running in that cluster. So I can see all of those different services that are running down here, including Spark 2, for example. So I'm going to take a look at that, and I can get some information about the services that are running there and the clients that are installed. And I can perform actions like stop or restart or delete services and so on in here as well. So it's important to be able to come in here and get a view of the services. Occasionally, if you've perhaps provisioned with a an under-resourced virtual machine size or something goes wrong, you might occasionally come in here and find that services have failed to start or something needs to be restarted. So it's good to be able to come into the Ambari dashboard and manage your services like that. Now, in addition to connecting over HTTP, we can connect over a secure shell. And to do that, we get our secure shell connection. And it really depends on whether you're running Windows or Linux or a Mac as your client operating system here. If you're using Windows, then you'll need to install some sort of SSH tool like PuTTY, which I've got on my machine. So I'll copy that host name. That's what I'm going to need. If you're using Linux or Mac, then you have a bash shell built in, and you can use that. Just open up a terminal session and connect using SSH. But I'm going to take that host name and I am going to run my PuTTY client. We'll just go and open that up. And I'll just type in that host name. I'm just going to increase the size of the font here so that you can see what I'm doing. So we'll just bump that up a little bit and open up that. And I get a console window like this. Now, the first thing that happens is it warns me that I'm connecting to a host that I haven't connected to before. So we haven't got that key cached in the registry. There's a digital fingerprint for this cluster. Am I sure this is the cluster I want to connect to? Well, yes, it is. So we'll just go ahead and log in. And this time I have to log in with my SSH credentials, not the HTTP ones. So it's important to remember the difference between those two credentials. And when I connect, I can log in, and I'm now connected to my Spark on HDInsight cluster. I've got a remote session to that in this console window here. We'll just widen that a little bit so we can see what we're doing a little bit better. And I'll go and clear that screen. Now, what I'm actually connected to, you can see here I'm SSH user at HN0-Spark01 or SPK01. So that's telling me I'm connected to a specific node within the cluster. I'm connected to head node 0. And I can actually get the entire host name of that node just by typing in host name. So there's the fully qualified name of that host that I'm connected to. But I'm connected to one host of many in that cluster. A cluster has multiple nodes. And that's important. So if I do a standard Linux command like ls of the root here, then what I get is a list of the files that are on the file system for that one node. So that's the local file system for that particular node. That's not the shared storage for the entire cluster. And that's important. If I want to work with the shared storage that's used by all of the nodes in the cluster, I have to use a different command. I use the HDFS command, and then I can use my ls root. And that gives me the output of the files and folders that are shared by all of the nodes in the cluster. So it's important to realize that when you're connected with an SSH session to the cluster, you're actually connected to an individual cluster node. And the local file system is available just using the standard Linux commands, but the shared file system, the cluster file system, is available using this HDFS, DFS set of commands. So important to realize those differences. But that's basically it. I've now provisioned my Spark cluster and I'm ready to start using it to process some data. The one thing we will be using a lot in this course are the Jupyter notebooks. So get used to this one. Again, I'll click that link. Because I've already logged in with my credentials, it doesn't prompt me, but it will prompt you for your HTTP credentials. And here's where we're going to create notebooks to run our code in this course. And you can see there are some existing folders in here. PySpark contains a whole bunch of examples written in Python. So it's certainly worth taking a look at those if Python is your preferred language. And Scala obviously contains some examples written in Scala. And again, there's some good examples of code to look at there. So we won't use those in this course, but it is worth being aware that those samples are there to help you learn how to do various common tasks using those languages. So there you have it. We've got our Spark cluster running there in our Azure subscription. And we're now ready to learn how we can use that to work with data and to build some predictive solutions.